Hello, dear participant. Welcome to a new tutorial from Logi tutorial presented today by my son Joseph and me. And today we are going to work together on a project which is about creating or controlling the Raspberry Pi using Scratch, MIT Scratch, which is a visual programming environment built by MIT. And for the Raspberry Pi, we are going to control not the Raspberry Pi itself only, but we are going to use the general input-output general purpose input-output pins in the Raspberry Pi to be able to make a LED turn on and off, which means that you can control the physical world or the external world using the Scratch with Raspberry Pi. Okay, ready, Joseph? Yeah. So let's begin. Okay. So we will move directly to our camera. We have like a set of two cameras here. One camera will be focused on our project and our Raspberry Pi, and the other camera is dedicated to get our pictures. And Joseph, if you have a question at any time, you are like most welcome to ask your questions. So first of all, let's start with the Raspberry Pi. Here what I have for that project is a Raspberry Pi connected to a power like adapter, which will provide the enough power to run that Raspberry Pi. And as you see here, my Raspberry Pi is inside a box. This is the standard box, the standard black box by Khiami kit. This is one of the kits, so this is provided by more than one kit. You can purchase that through any kind of provider that you like. So the main thing here with that box, that it will keep the pin like the 40 pin of Raspberry Pi out for us to use. So those are the 40 pins of a Raspberry Pi, so we can use those to connect Raspberry Pi to like external component. So first of all, before going into details, those called like GPIO, so general purpose input output pins. So this is the main thing with that. We should be very careful when attaching anything to our Raspberry Pi. Any kind of component that is not suitable to be attached to Raspberry Pi will cause the Raspberry Pi to be damaged. So be careful and follow the instruction very carefully. So in our project today, we are going to use a breadboard. So, and a small explanation about the breadboard. The breadboard is a board that will be having like a kind of, in this case, we will be having like three main zones. So this is zone 1, this is zone 2, and this is zone 3. So in the zone 3, which is the bigger zone, we're having that part where each column content is so we're sorry, we will be having some kind of background noise. This is caused by the rain. It's raining outside, so, and it's raining heavily outside, so we're sorry for that. This might cause some kind of background noise. So let's continue. Joseph, are you ready to continue on that? So Joseph, do you know like what is like mainly here when we have anything that we want to connect together, if we are using that block, so we are using the vertical line. So anything here on the vertical line is connected together, which is not the case for the upper part, where each like all the holes here on the horizontal part are connected together. So all the holes here on that row are connected together, and all the holes here on that row is connected together, and all the holes on each one of those columns are connected together. Two columns are not connected together. So if you put something here and something here, those are not connected together. Okay?
But why?
Why? So we can do some kind of isolation. So sometimes we need to use each line for different component. So we will use that line here and the other line for other type of component. But if we want to connect two of those columns as example, we can use a small cable here. So we have those small cables. I think those are provided here. Can you pass me, Joseph? I think we have one of those here. No. Joseph, I think I have a box there. Can you pass me that one? There's a box that contains lots of wires. There, up, behind here. Did you find anything? No? Okay. Yeah?
Is this it?
Yes, that's it. Please come back. Thank you. Joseph has been very helpful here today. So, and this is our, okay, I think it's, one moment, this is the cable line that, also our small, like, we'll just label cables or just wires that we can use in our projects. I'm sorry for that. So we can use any of those as example. Those are wires, but those has that shape. Those are not resistant, no nothing. So only wires. So if we do something like this, so we are attaching with that column with that column. So if we want to attach any column with other columns, so we can use something to attach those together. But without having that attachment, any of those will be totally separate from the others. But as I mentioned, for the upper one, like for the horizontal one, I'm sorry, for the horizontal one are like connected together directly. So all those holes here on that row are connected together, and on that row are connected together. For me, it's a good practice since they have like the plus and minus here. So I normally connect the negative pole to that line, so I can, or the ground. Yes.
What are?
Do you have any question?
Yeah.
So what question you have?
What are these holes at the top?
At the top. So let's go and see here.
Like why? If you do this, it just
Sorry,
connects.
just show your friend with use that to show what.
If you do this, if you connect this to this,
Yeah.
what will happen?
If I connect any one of those holes to any one of those holes, that line, all that line, and that line will be connected together. All the,
I know, but
yeah.
what if you do like this? That.
You're using the same. It's not a good thing. Normally, it's a bad practice always to attach the same component to the same column here, because you're now creating a short circuit. So because those are already connected together, you are using another connection to connect those together again. So this is not good. Normally, when you want to use any component, normally the component will go between two parts, between this and this. So between this and this, or between one of those and another one of those. So normally this is the way. Okay. So if you find yourself using the same column, be very careful. Or the same row here, be very careful. Sorry. The same row or the same column, be very careful. Okay. So this is, we spoke about the breadboard. Yeah.
If you put this on here, what will happen?
So same. This is the same. Joseph now is trying to use the same like line for the component, which all those this line holes are connected together. So what you're doing is creating a short circuit here, and this is not right. Okay, so you cannot normally, if you want to use something like that, you will use that one. So this is totally separate from that one. Otherwise, if those two legs, you're connecting those two legs together, if they want those two legs to be connected together, they will make those one leg. And yeah, Okay, we have two legs because we need two poles for that. You cannot put those in connected like circuit. Okay, so from that point of view, what I will be using is I'll be using the breadboard, and we will need some kind of wires. Yes.
What is this for?
Those are different connection with different length. So to be able to use those, I normally prefer to use those things. Are like more convenient for me.
But this connects all of it.
Why? It's already connected here, but normally when we use that, we don't use it just to connect the same line. We use it to do something like this, as example.
Oh, like that.
Yeah. With that, you connect all that, that line as example with that line.
Oh, okay.
Okay? It's not to connect those two together. Or just to connect that line with that line. So with that, this and this are connected together now. Okay? So let's go back to our work. Thank you for your questions, Joseph. Now we spoke about the breadboard and everyone knows how to use the breadboard. Okay? And we will need some wires, normally male, female, and male, or female, depending on your configuration. So the female will be normally used for the Raspberry Pi pins. So normally you use the female one for Raspberry Pi pins. The male one for the to use with the breadboard. So like anything will go here with the breadboard. Okay. So one thing, and I will be explaining the ohm law later on in another a video, but for now you will notice that I'll be using what we call a resistance. Okay, and normally, as you see here, I don't know if this is obvious, this is not clear. This has colors. You see those straps here on that resistance. So this is like 330 ohm. This is 330 ohm, Joseph. Do you know why this is 330 ohm?
Why?
So this is kind of something to resist the current, okay? And we will explain later on why we're using that one. But normally, what we are interested in is the value of the resistance. So to get the value, normally with your kit, you will be having normally a guide for the resistance. Can you bring me that colorful, nice paper? Thank you, Joseph. Thank you for your help, Joseph. Okay, this is the one, and as you see here, you see a resistance, and you see that the colors means the value of that resistance. And what you can see here, that as example, the one that I'm using, it's not very clear here, but the one that I use here has the first orange color, which means that the tolerance of that one is about 2%, and then it has, or I'm sorry, this is the black, yeah. So I'm sorry, this is the brown one. So 1% the tolerance. So the value of this one can change by 1%. Then we see the line, the next line is black, so that means it will be multiplied by 1. And you see that we have one line which is black, then two orange line, and the two orange line will reflect 3, so 330, which means 330, which is 330 ohm. And we will be explained in a different video what's mean ohm and what is the relevant of how ohm
Daddy,
law is relevant. Yes, please ask.
can you bend these?
Bend that one for sure. Like we can bend it, but we should be very careful because to not destroy the legs. Okay. So what I will do, going back to our breadboard, what I will do is to depend on that line to provide the power for our breadboard. So I will put it here. Okay, so all that line will be getting a positive like pole. Okay, and where I get the energy from, since what I'm using is only a LED and the LED does not need lots of energy, so this is why I can depend in a way on my Raspberry Pi to generate the power for that. So I will attach that to the first leg here. You see here, okay, that first leg here. The first leg generates 3.3 volt, which is sufficient for my LED. Okay, but again, I'll put the LED here. I don't know if that's clear enough. Again, okay, let's have some extra light here. Okay, I'll put the LED here. This is lots of light. Okay, so I'll put the LED here. Since all the row here are connected, is connected together, all the holes here are connected together, so I can use any one of those holes here to attach my LED. Okay, and as you see, I put the longer leg. You see here, I have longer and shorter leg. The long leg is connected to the positive part. Okay, so how, Joseph, do you know how to differentiate the positive from the negative? On that LED, which one is the positive, which one is the negative?
This one's the positive.
Because
it's taller.
It's taller, yeah. So since I have the positive like connected to here, so I can just have that one, the longer leg, connected here. So with that thing, I'm having the longer leg connected to the positive. Now, when I connect that to that place here, it's not clear enough. Sorry for that. Again, try to minimize the light. So, trying to find the best way to show you that. Okay, here, yeah. So as you see here, I'm using the other leg is touching that part here. So I'm not putting both of those on the same line. So I'm using that middle part to put the other leg here. Okay. Now I need to attach my my resistance. So I'm using that part here to that part here. Okay, again, you notice the legs?
What leg?
Yeah, you see that leg here is on the same line with that leg here. That means those are connected together.
Oh, okay.
Okay, now the other leg on the other side. Why? Because I cannot put all, because this is a component, and normally component jump from one zone to another. I cannot put the both of them on the same zone. Okay, so now continuing on that part, we mentioned that we will use the black cable here, like this is 2 males, and we will attach it to the other part on the same column as that one. So you know, we mentioned that everything on that line are connected together. Yes, Joseph. So with that, we connect the leg to the positive pole, then the other leg to that leg, not directly, but through the breadboard. Then that leg goes here, and since we're attaching that black wire here, so it's similar to attaching that directly to the leg here. Okay, so that part will go to the negative. So anything on that line, Joseph, anything on that line, I'll make it negative. Okay, any question? So this is positive. I'm using all that line for the positive and that line for the ground. Okay, so I need another cable just to attach that ground here. Sorry, I need male, female, and I need something black, maybe. I'm searching for black cable or dark cable, maybe. This is a black one. Okay. No, it's not black, dark. Yeah, this is black. Okay, now okay, this is, I need male, female. Male, female, where's that? Male, female, this is female, female. This is male, female, and I need a black one of that. This is one. So here I'm attaching the negative here to that part, to the leg. Now the leg that I will be attached to is the ground. So if you see that like layout of the legs again, so the third leg here is ground. Okay, on that side, the black one. So I'm attaching that 1, 2, 3, and this one is the black. Now with the connection that I did now, if I turn on the Raspberry Pi, I'm using that switch to turn on the Raspberry Pi. If I turn on the Raspberry Pi now with that switch, you'll see that this is turned on.
How?
So you see that one is on. I'll move that light, lots of lights here. I'll move the light and we are connected now. Yeah. So, but as you see, this is like on all the time because I did like close this circuit. So like from the positive coming by the white color wire, going to the first leg here.
Papa, what
Yes.
if you do this?
Don't touch that. But yeah, just like put the anything just to show you.
What if you take it off?
Should I switch it off?
No, what if you take this thing off?
It will shut down. But normally we don't change anything if we have our Raspberry Pi on. So
okay.
we don't do that manually. If we want to change thing, we can put like kind of button on the way or to do something. So let's try something. I'll switch off that. I'm switching off like totally. And I'm adding, let's add a button. I think I have some buttons here. Maybe a small button. Okay. Let's add the button. This is a very small button. I'm sorry for that. Very, very small button. Yes. Yeah. I don't know if you see that. Very small button. Okay. We can add that. Okay. Thank you, Joseph. He's telling me that they cannot see it. We can use that to switch on and off just to see if this is work. So what I will do here is to put the button here directly. I'm sorry if this is not that obvious here. So as you see here, I'm putting the button here. Okay. So what I will do, I will use, instead of getting the current directly from here to there, I'm passing through that button here. So I'm attaching that to this leg of the button. Okay. And going out from that leg to the other leg here, just to make it as a switch. So everything will keep this being the same. I'm only adding the effect of that one here to there. With that, I'm using here that switch. You see that this is the switch and this is the first leg, and I'm keeping everything the same, but I'm passing now the current will be passing through the button now. Okay, through the button.
What if you press the button?
Now if I turn on that, nothing will happen.
Now
if you press the button, you'll see when pressing the button, I'm having that light turning on.
Okay.
Okay, so this is using the button itself. Okay, but all that is done through the button. I'm not controlling anything using the computer till now. Okay, I'll switch off my Raspberry Pi again. Now we will try to use, instead of using the with that, I'm connecting the currency directly to the component. But now what I will do, I'll remove that button. I'll be attaching the current directly to the component. But instead of having the current, the positive going directly from 3.3 volt, I'm going to use one of the GPIO ports. So I'm going to use that port number 17 here, GPIO 17, which is 1, 2, 3, 4, 5, 6. So I will count 6. 1, sorry. Again, I need light. So 1, 2, 3, 4, 5, 6. So I'm using the 6th pin. 6th pin. Okay, 6 from that side. From the pins on that side here. Okay. Now I'm not connecting through the 3.3. When I connect directly through the 3.3, Joseph, I have the current always available. But now I have that through the GP17, which is the GPIO 17, which is one of the ports available to scratch to control. Now I will say that that part of our project is done. So the hardware part of our project is done. Let's move now to the software part. Okay, so Joseph, are you okay till now? Do we have any questions? Do you have any questions now?
No.
So do you have any question regarding how we connect those components together? No. So can I ask you something?
What?
So which leg in a LED is the one with the positive that should be connected to the positive pole? Which leg? How do you differentiate which leg to be connected to positive and the leg that should be connected to the negative?
This leg.
Yeah, this one.
White.
Yeah, it connected to the white, which is the positive. But why we connect that leg?
No.
Because it's taller than that one. You remember?
Yeah, I remember. But this one, when you look like this, it's a little bit brown.
Okay, the issue is only with the taller one is the one that will be connected to the positive. Okay, so with our project hardware part done, so we will move to the software part where we will be working on the Scratch. Okay, let's go back together here. As we mentioned, the first part was related to creating the hardware part where we create our project. We did use our Raspberry Pi with a breadboard and some wires and with a single LED with the resistance to 330 ohm. And we will be speaking about the Ohm law in different video as we mentioned. So the second part now, Joseph, this is your preferred part. So the second part is to create the software for that. So we will be using the Scratch to be able to do that. I'll move directly to capture the screen from our computer to be able to use Scratch. Okay, ready? Let's start. So to be able to use Scratch, I'll be using the VNC. So why I'm using the VNC, I need to use Scratch on the Raspberry Pi, so it will have access on the Raspberry Pi itself. So what I will do here is I have a connection prepared to access my Raspberry Pi, and I'll be double clicking that. So with using the VNC, it's similar to the issue that I'm working on the Raspberry Pi itself. So like connecting the mouse and the screen and the keyboard to that Raspberry Pi. But using the computer is much easier, yeah, like in controlling it remotely. Okay, so this is why I'm using that approach. I can just connect everything to my Raspberry Pi and do everything directly on the Raspberry Pi itself. So, but now it's much easier. I'm double clicking on my Pi and I'm providing the credential. The Pi that I'm using, the default, if you're using the VNC, the default credentials are Pi and Raspberry. Okay. Okay. And I can set remember password. Okay, not Raspberry Pi, only Raspberry. Okay, I'll maximize that. The interface that I'm seeing here is the interface of Raspbian, which is installed on my Raspberry Pi. Okay, so what I'll do, I'll open Scratch. You know Scratch, Joseph, yes? Mm-hmm. So I'm using Scratch, the older version of Scratch, because we in our tutorial we might be using something to remotely access the Raspbian. So this is the version 1.4 and the Scratch 2 is the second version. So I'll be using the old version here. Okay, clicking on Scratch. So what I need to do is to create now the logic to be able to light that LED on and off. Okay. So first thing that I will do, normally when I interact with Raspberry Pi, I will use something called broadcast. I will send messages to the Raspberry Pi. So I will do that through using the broadcast concept. But the first thing that you should remember when you use the Raspberry Pi with the GPIO is to turn the server on, the GPIO on. Okay, so the first thing that you need to do is to drag, to go to control, and of course, when click, this is to click the green button, so to start our code. Then to go, if you scroll down, you will find something called here. So where's that? Broadcast. Yeah, this is the one, broadcast. So broadcast. So the message that we'll be adding, we'll click on the small arrow here and we will click new. And the message that we will be adding is to GPIO server on. This is to tell the Scratch to turn on the server. Yes, Joseph? So okay, here. So this will turn our Raspberry Pi server, GPIO server on. Then the next step is I should specify which port I'm using here. So which port I'm using here? You remember, Joseph, which port I'm using?
17.
17, which reflect, as you remember, to the 6th like pin. You remember in our I will go back to the image itself if you like to switch to that one. You see, this is the one that I'm attaching to the 6th port. So GPIO 17. This is the number is GPIO 17. Okay. Going back to our VNC. Sorry. Going back to our VNC. And sorry, we should go to the session itself. Okay, so the broadcast itself, as you see here, this is GPI server on, IO server on. The next thing is to specify that I want a specific port to be used to output. Okay, so I will use broadcast also to do that. So with broadcast, Now, what should I use? Like, I should set which port will be used for output. So I should say like GPIO 17 out, I think. So I should say GPIO 17 out. So this will tell the Scratch that set the GPIO number 17 as output port. Okay. Now we will go like and try to turn on that button. So we will broadcast, delete. So we will broadcast GPIO. So this is here, GPIO 17 on. Okay. Let's try to run that one. You will notice that when that the light is on. Now if I say broadcast GPIO 17 off, it will turn off. Just to show that in a loop, I will add a loop here, like forever loop. And I'll add the GPI on inside that one. Then I will wait a little bit. So I'll use wait for half a second. Then I'll use broadcast again to turn it off. So I'll say GPIO off. GPIO 17 off. Okay, let's try to run that script and to see. You see that it's blinking. I don't know if this is obvious, but if we wait, let's add another wait here and another 0.5 after switching off. This will make it slower and more obvious. So you see it's blinking. Okay. So again, let's review. Can you tell me what we are doing here, Joseph? Like on when we the first one is to decide if we click that green flag, this will go on. Yeah, this will start our script.
You can just use one.
Yeah, here.
Two.
Yes, we can do that, but like this will make it off after on, like for a while. Yeah, we can do that for sure. But the pattern of yeah, it's working, but you see how like it's off for a very short time. I don't know why that is happening. Like,
okay, then I'll put it back.
You can do something like putting that after put that off, like drag that part here, that block. Yeah.
What?
Yeah, you should drag it out. Just you can pull that part here, the broadcast part, and put it directly here maybe, and put that here. This will be not very effective, but let's try it. You see it's turning on for a very short time. Okay, so we need for sure to have those two waits before and after. So this will make it more obvious. So you see, this is very obvious here. Okay, good. Are you satisfied? So our project is done. Thank you, Joseph. Any questions?
No.
And I'm sorry for taking too long. Okay, so this was very good. So I'm going back to our screen. Wow, this was perfect. Thank you, Joseph.
You're welcome.
Yeah, this was very good job. Like very good job. So we finished our project and it works fine. And today we did cover the issue of controlling a Raspberry Pi GPIO through Scratch using also VNC. And we did do all the wiring and explain a little bit about how to create that connection between Raspberry Pi and the physical world. Thanks again, Joseph, and thank you, everybody. I hope that you join us in other tutorial provided by Logi Owl, and hopefully I can convince Joseph to join me the next time. Thanks a lot, Joseph, and see you again soon. Bye-bye.
Bye-bye.
Bye.